Hello everybody, I'm Nick, the Raging Cajun from the Acadiana section of Louisiana, and a consummate tinkerer. You might be a tinkerer if you plug yourself in the wall before you could crawl. You might be a tinkerer if you figured out what a flyback transformer was the hard way. You might be a tinkerer if you sniffed hot soda before you tried smoking. You might be a tinkerer if you built something that caught on fire. And you are a tinkerer if you built something that caught on fire on purpose. You know you still got it when you can solder parts that are so small they're smaller than a dime. Takes a magnifying glass to put them on. Or you can solder on QFM parts with all the leads underneath. You know you're losing it if you use a tree for a stepladder and forget where to step. So if JFK were a ham, here's what he might say. We choose to go to HEO. We choose to go to HEO in 2 years and do other things, not because they're easy, but because they are hard, because that goal will serve to organize and measure the best of our energies and skills, because that challenge is one we are willing to accept, one we are unwilling to postpone, and one which we intend to win. Hams have a rich history in adding to the state-of-the-art of satellites. For example, AO1 was the first NGO to get into orbit in 1961, probably the first rideshare. AMSAT and its predecessors had to convince NASA and the Department of Defense that we could build satellites that do not compromise their primary load. AMSAT was the one that showed that you could use commercial off-the-shelf parts and go into space. Our last major contribution was microsites, and that was 2 decades ago. It's time we get off our duff and start contributing again. So what does it take to go to HEO? 2 important tools. 1, just blissful ignorance, and 2 is brute force. So what does it really take? Well, I think technology is caught up with our AMSAT budget, so we need a rocket. Well, NASA, via the Atlanta program, makes a 3U-cube ride to LEO doable. And for example, we will fly a Fox, FunCube, Cape, and others. So what is a 3U-cube? And is it big enough? Well, a 3U-cube is a device that's 12 inches by 4 inches by 4 inches and must weigh less than 6 pounds. And I've always been asked, is it big enough to do anything in HEO? And I believe it is. I've also been asked, how much power can you generate out of a 3U? Well, today, with a credit card, we can actually purchase a unit similar to the one in the picture below that produces 50 watts. And if we need more and we're clever, we can build one that does better. So what else do we need to go to HEO? Well, we're going to need a guidance system. And the good news is that we can now buy or scrounge off-the-shelf GPS devices that work at our orbit. We can buy or scrounge reaction wheels. We can buy or scrounge or build magnet talkers. We can buy sun sensors, and all of the above will fit in a 1U form factor. And all these devices above have flight heritage, reducing our risk. I've been asked, how about the link budget? Well, if we get out to 50,000 kilometers, we have a downlink on 2 meters. We take a bandwidth of 2.4 kilohertz. We produce the power out of the antenna at 1 watt. We have a gain on that satellite of about 6 dB. We have antennas at the ground station of 14 dBs. That would produce a signal-noise ratio of 16 dB. Pretty good for voice. And I think all this can be jammed into about a half a U form factor. And remember, if we want more signal on the ground, we got 50 watts of DC out there to do that. So now we're going to need a frame. The good news is that there are now folks building frames out of composite materials. This perhaps could save us 600 grams over an aluminum frame. Propulsion system. Propulsion system is a long pole in the tent. And here's where the ink is not quite dry. But there are ion engines that can lift us from a low Earth orbit into something more friendly to us. Or we can start from a GTO orbit and raise the perigee so that we can live longer than a few days. How do these engines work? Well, these engines convert energy from the sun, and we will generate some ions from either water, Teflon, or some other benign fluid, and we will accelerate these ions to produce thrust. Now, these things don't produce a lot of thrust, and sometimes they're described as mouth farts. But you know, if you push long enough, there's no material, no thing out there except gravity will come. We can get to where we want to go. All we have to do is be patient. This is still a challenge, however. Right? And here's a picture of an ion engine. And there's others. So what are the next steps? Well, first of all, we got to affirm our vision that we want to go. And then we have to choose leaders that will lead us there. And the next opportunity we have to submit a grant is November 26th. And after delivering this this talk at the AMSAT conference in Houston, there are now several of us working on that. So let me leave this with a little Cajun humor. You know, down area, we have two Cajun philosophers who recently got their extra, and their names are Thibodeau and Boudreaux. You know, and Thibodeau and Boudreaux are sitting out in the bayou drinking some 807s. And Thibodeau said, Boudreaux, he said, you know, it might be nice to go visit the sun. Boudreaux said, yeah, it would, but don't you think it's going to be kind of hot? Thibodeau said, well, Boudreaux, we just got to go at night. 73s, hope to work you on a HEO.